Okay, hello Hodge Hill pupils. So today's lesson is on arc length. Um, in order to access this lesson, you're going to need a calculator, pen or pencil, and some paper, and also a ruler for some neater diagrams, although the ruler isn't mandatory. The calculator, however, is. You will need that calculator today. So the aim of today's lesson is to be able to work out the arc lengths and perimeters of sectors. Okay. Now there's a couple of words there that you may not be familiar with. Sector is one of them. So sector refers to part of a circle. Arc talks about the curved part of the circle. So an arc is essentially part of the circumference. Okay. So you can find the circumference using this formula, pi times diameter. Now, as you should all know, the diameter of a circle is double the radius. So if a question gives you the radius, you can double it to work out the diameter. And the diameter is defined as the distance from one side of the circle to the other, which passes through the center. So usually this will be represented just by a straight line going through the circle. You can work that out, or you can see it from a diagram. Here's an example. So I've been given the diameter of this circle. The diameter clearly from one side to the other side is 10 centimeters. So to work out the circumference, I'm going to put in my calculator pi, this symbol here, times 10. If you don't know, the pi button is at the bottom of your calculator. You need to press shift and the button that says times 10 to the power of, the standard form button, and that will give you the pi symbol. So times 10, which is 31.4159, etc., etc. Question will usually tell you to round it, maybe to one decimal place, maybe to two decimal places, maybe to significant figures. 31.4 centimeters. Okay, so this diagram shows you a circle that has been cut into two parts. Okay, you've got this sort of blue section here, and you've got this green section over here. Now, both of these parts are called sectors. Okay, this would be referred to as the minor sector, and this green one would be the major sector because it's the larger of the two. Let's now go through the other bits of the other definition. So I mentioned arc earlier to you. That is called the minor arc. That's what I was talking about. The part of the circumference, part of the curve, that is on the smaller sector, that's called the minor arc, and therefore the green one is called the major arc. Okay. Arc, as I've said, is part of the circumference. If you're the kind of student who likes a sort of analogy, for example, you can think of this as a pizza. You can say the sector is the slice of pizza. The red section, the arc, is the crust of the pizza. I've already mentioned that's the minor sector. And then finally, this symbol here, this Greek symbol theta. So you'll be aware of the Greek letter pi already. Theta is another Greek letter, and it's used in maths typically to represent unknown angles. So when there's an angle that I don't know, I'll use the symbol theta. Now, this is how you work out the length of an arc. You would do the angle, theta, divided by 360, which represents the whole circle, times by the circumference, the entire circumference. So effectively, it's the fraction, this is a fraction, of the circumference. So how much of the circumference do we have? I'll cut this bit out. Thank you for waiting for me. Okay, I'm going to start again. I've already gone through the sector and letter theta, but there they are written in case you missed it. Please feel free to copy any of these notes that you require. As I've said, though, the most important thing you understand, though, is that this formula is how we work it out. Now, you should know that the way to work out circumference from the previous slide was pi times d. So another way of writing this formula, arc length, is theta over 360 times pi times d. Right, let's have a look at an example. So here you can see a pretty straightforward diagram. You've got a radius given to you over here. So you've got the radius here, 11 centimeters. You've got angle theta, which was, before it just said theta, this time we know the angle is 70. And the question says work out the arc length and work out the perimeter. So the formula you'll recall from the previous slide was theta over 360 times pi times diameter. So for this question, there's a couple of things you need to do with that because you haven't been given the diameter. So 70 over 360, that bit's pretty straightforward. So the angle over 360 times pi times, now instead of using 11, because as I said that's the radius, you need to double that, which is 22. So angle over 360 times pi times diameter. You'll put that in your calculator and you'll get an answer. So I'll do that now in front of you so you can see. You can press the fraction button if you like. 70 over 360 times pi, so that's down there, as I said, the times 10 button, times 22. And that's given me an answer of 77 over 18 pi. Now, you need to be comfortable using this button here, SD, which basically changes the format of the answer, converts it from standard form into decimal form, or as a normal number into a decimal. So that is now my answer as a decimal, 13.43903, etc. Now, be in the habit, please, students, of writing all of it out, or more than a few digits, and then rounding it. The reason we do this is to save a mark. In case you make a mistake rounding now, in case you do something silly in the exam under the pressure of exam timing, you forget that rounding to one decimal place means you look at the 3, you don't look at the 4, for instance, and then you round this to 14 for some silly reason. You can still get full marks because I've written all of this. So I'm now going to round it to one decimal place, 13.4 centimeters. But if I rounded that to, I don't know, 15 centimeters because I was crazy, I would still get marks because I have written the first line with all the detail. Okay, part B of this question is to work out the perimeter. Now, perimeter, you'll be familiar with this from year 7, even earlier than that, possibly at primary school, means the distance around a shape. Now, this shape is slightly new, but aside from that, everything else about the question is familiar. So perimeter means the distance around it. So if you're looking at this shape, I'm talking about this line, and this curve. So all you need to do is the radius plus the radius again, plus the arc that we just worked out, this arc here. So I am going to use the answer that's on my calculator. I haven't gotten rid of that answer from my calculator. The reason we do this is to preserve the accuracy of the answer. If we were to use our rounded answer, we may potentially lose a mark because, well, firstly, if you've rounded it wrong, you're going to make the same mistake again. But even if I rounded it right, the fact is I've gotten rid of some of these numbers, right? I've effectively ignored 3903. So don't use the rounded version. Go back to your calculator and use the original full version. So 11, add answer. And that gives me a perimeter of 35.4 centimeters. Please note the units I've included on both answers. This is a distance, not an area, so we're talking centimeters or meters or millimeters. That's it. So you've got the answer again there if you didn't like my handwriting. There it is there on the PowerPoint. Here are 2 for you to attempt. Okay, so for the first pink question, you need to work out the arc length, just this arc here. And for the green question, the second question, you are needing to work out the perimeter. So don't just add on the radius twice. Okay, have a go at those now. Please pause the video and press play when you want to see the answer. Okay, so first one. Straightforward enough. 40 over 360 times pi times 12. Just don't forget, you need to multiply radius by 2 because you've been given the radius and you need the diameter. Second question, Apologies, yeah, there's the final answer, 1 decimal place. Second question would be 120 divided by 360 times pi times 10, and then just add 5 again because I want the perimeter, so that's 20.5. I haven't shown the working out there, but I've just explained it. Please rewind the video and listen back if you've made a mistake there. Here is the main activity for today's lesson. If you are in set 1, you need to do both of these activities, so I'm expecting to see 2 pictures uploaded. One picture with these 4 answers and 1 screenshot of your score. If you are not in set 1, then as a minimum, I'm expecting you to just do these 4 questions. As usual, take a picture of your answers and upload that to class charts. That will complete today's remote learning. Thank you very much.